Hello, my name is Nitya Kalyani. The topic I am going to talk about today is rotor resistance control of a three-phase induction motor. Now, let us start from the beginning. What is a three-phase induction motor? It is a type of motor that does not require any starting device, which means this type of motor they are also known as self-starting induction motors. It consists of two parts, which are stator and rotor. Now, a stator of a three-phase induction motor is made up of a number of slots to construct a three-phase winding circuit to which we connect the AC power supply. Now, we can arrange the three-phase winding in such a way that they produce a rotating magnetic field when we switch on the AC supply. Now, let us talk about the other part, which is the rotor. Now, the rotor of a three-phase induction motor it consists of cylindrical laminated core which has parallel slots that can carry the conductors. Now, the conductors can either be made of heavy copper or aluminum bars which are fitted in each slot and they are short circuited at end by end rings. Now, let us discuss about the working principle of a three-phase induction motor. Now, when a motor is supplied with a three-phase AC supply, the three-phase stator winding it produces a rotating magnetic field which has a displacement of 120 degree at a very constant magnitude and it rotates at synchronous speed. In this presence of magnetic field of stator, the rotor conductors are also placed. Hence, according to the Lorentz principle, a mechanical force acts on the rotor conductors. Now, the diagram given below is of slip ring three-phase induction motor. Now, the rotor conductor's rotation it can also be explained with the help of Lenz's law, which states that the induced current in the rotor it acts in such a way that it opposes the cause of the production. In this case, it is in opposition of the rotating magnetic field. This results the rotor conductors to start rotating in the same direction as of the stator conductors. Now, the relative speed between the stator field and the rotor conductors it causes the rotor to rotate in this particular direction. The synchronous speed of the machine depends on the number of poles used and also the supply frequency. The difference between the actual speed of the rotor and the synchronous speed is also known as slip. Now, let us discuss about the types of induction motor based on rotor. There are two types, which are squirrel cage induction motor and slip ring induction motor. Now, squirrel cage induction motor has the name squirrel cage because the rotor inside it looks exactly like a squirrel's cage. This type of rotor is made up of a cylinder with steel laminations which are highly conductive and metal embedded into its surface. Now, if we supply an alternating current to it through the stator windings, a rotating magnetic field is produced. Now, let us discuss about slip ring induction motor. It is also known as asynchronous motor because it rotates at a speed which is not equal to the synchronous speed of the machine. Now, this type of rotor is also known as worm type induction motor. It consists of a cylindrical laminated steel core and a semi-closed groove at the outer boundary to accommodate the three-phase insulated binding circuit. Now, let us move into the actual topic we are discussing, which is the rotor resistance control method. It is a type of speed control method which is used in three-phase induction motor, where the speed of the induction motor is controlled by connecting an external resistance in the rotor circuit through slip rings. Hence, this method is not applicable to squirrel cage induction motor. The given diagram below is of slip ring induction motor with an external resistance added to it. Now, the conventional method for variation of the rotor resistance is done by inserting a variable rheostat in series with the three-phase winding of the motor. This method of speed control has many problems and was not economically viable. Now, the variation of the rotor resistance can also be done using power electronic devices such as transistors, which is a more efficient method and will be discussed later as static resistance control method. Now, the torque equation of a three-phase induction motor is given as below, where R2 is the resistance of the rotor, R1 is the resistance of the stator, and S is the slip of the induction motor, and omega S is the synchronous speed. Under normal operating condition, the equation is given as below, where the slip is directly proportional to the torque and the rotor resistance. Now, according to this equation, at a constant torque, the slip is directly proportional to the rotor resistance. So, if the resistance of the rotor circuit is increased, the slip is also increased, which means the speed of the rotor is decreased. This method is applicable only to slip ring induction motor and not to squirrel cage. The given below characteristics is between speed and torque. So according to this characteristic, at normal operating condition, the slip increases with an increasing torque, hence the characteristics is very linear. So for a fixed load curve, the speed is acting downwards from the point N1 to N4. So this method, it has an advantage of achieving maximum torque at the starting period. Now, this method, it suffers from drawbacks, which are the rheostat, which is used to vary the resistance per phase. It causes an imbalancing of rotor, and in case of large machine, the size of the rheostat will be large, and in such cases it is not easily portable. So to overcome these drawbacks, we move to an efficient method, which is static rotor resistance control. In this method, the AC output voltage of the rotor, it is rectified by using a diode bridge rectifier and fed to a parallel combination of fixed resistor R and a semiconductor switching transistor TR. Effective value of the resistance across the terminal, it is varied by varying the duty cycle of the transistor, which in turn varies the resistance of the rotor circuit. In this circuit, inductance can also be added to reduce the ripple effect and discontinuity in the link current. Now, the given below diagram shows the rotor resistance control by semiconductor converters. Now, a closed loop speed control scheme with inner current control is shown. Here, the rotor current IR and ID has a constant value at maximum torque point, both during motoring and plugging. So, if the current limiter is to be made to saturate at this current, the drive will accelerate and decelerate at the maximum torque point, giving it a very fast transient response. Given below is the diagram for the closed loop speed control. Here, the advantages of static rotor control methods are it provides a very smooth and stepless control, and it has very fast response. It requires very less maintenance. It is very compact in size, and the rotor resistance remains balanced across the three-phase windings. Now, let us talk about the advantages and disadvantages of this method. The advantage of this method is that it is very simple. So it is possible to have large starting torque, low starting current, and large values of full load torque at a very small value of slip, because slip is directly proportional to the torque and the rotor resistance. Now, it has several drawbacks, even if it has some advantages. Now, the drawbacks are, in order to vary the rotor resistance, it should be necessary to connect an external variable resistance. Hence, this type of speed control technique can only be employed on slip ring induction motor, which are provided with rotor terminals outside. Now, for a case of squirrel cage induction motor, there are no rotor terminals, so this method is not applicable. Now, the second drawback is that it is not very efficient, because the additional resistance and operation at high slips causes losses of energy. Now, loss in external resistance and loss in carbon brushes at high slip operation also causes wastage of energy. Now, let us discuss some application of this speed control technique. This method of speed control, it is used in cranes, waterliner drives, and other applications containing intermittent flow, because of its low cost and high torque capability at a very low speed. This speed control method is also used in fans or pump drives, where speed variation over a very small range, it can be near maximum or when top speed is required. Thank you.